In this video, we shall derive the expectation and variance for the normal distribution as a continuous distribution. For more on this topic, you need to subscribe to this channel. Of course, the PDF, which is x, mu, and sigma square for the normal distribution, is given as 1 all over sigma square root of 2 pi exponential negative x minus mu raised to the power of 2 all over 2 sigma squared. So this is the PDF, that is f of x. So we shall be finding the expectation and the variance. For more on this topic, you need to subscribe to this channel. First, the expectation of x for the continuous distribution is given as the integral from negative infinity to infinity x multiplied by f of x dx. So this is the expectation of x, and this is the PDF. So we multiply it by this variable here. So it means we have negative infinity to infinity x multiplied by what we have here, 1 all over sigma square root of 2 pi say exponential negative 1 all over 2 x minus mu squared all over sigma squared then dx. This is our expected value of x. The next thing to do, we can say let c be equal to x minus mu all over sigma, which implies that x minus mu is equal to sigma t. So if we take dx, or we say x, it also implies that x is equal to mu plus sigma t. It then means that dx is equal to sigma dt. So this is called change of variable techniques. The next thing to do is to impute what we have here, x is equal to this, and the x will now come to this. We impute the whole of that into this. It then means that our expected value of x will be equal to, we have the integral from negative infinity to infinity. Our x, which is this, our x is equal to this. So we have mu plus sigma t. We also have multiplied by our exponential multiplied by 1 all over sigma square root of 2 pi exponential negative 1 all over 2. Then we have the whole of this as t squared. We have our dx to be this, so we have this dt. Of course, we can bring this up. We can also bring this up to this place to give us sigma all over. We bring the whole of this sigma into 2 pi integral negative infinity to infinity. Now we are left with mu plus sigma t exponential negative 1 all over 2 t squared dt. So this is what we are left with. Of course, this will cancel this to give us, now we have 1 all over square root of 2 pi into negative infinity to infinity. This will multiply the whole of this to give us mu exponential negative 1 all over 2t squared. We are also multiplying this by this, which is plus sigma t exponential negative 1 all over t squared, then dt. Dt is acting on all of this. So we can separate this to give us mu into the integral of negative infinity to infinity 1 all over square root of 2 pi exponential minus 1 all over 2 t squared dt plus the integral negative infinity to infinity sigma t all over square root of 2 pi exponential negative 1 all over 2 t squared dt. Of course, this is now our expected value of x. So we've succeeded in separating the whole of this. Now, we should note that the whole of this is equal to 1, while the whole of this is equal to 0. It then means that our expected value of x will be equal to mu multiplied by 1 plus 0. It then means that mu is our expected value of x. So we have our expected value of x here to be mu, because this is 1, this is 0. So mu multiplied by 1 plus